Okay, another related rates question. Here we have car A is traveling west at 50 miles per hour and car B is traveling north at 60 miles per hour. Both are headed toward the same intersection. So the situation is A is going toward the west and B is going toward the north. So they are going toward each other, right? And it says at what rate are the cars approaching each other when car A is 0.3 mile and car B is 0.4 mile away from the intersection. So as always, I will draw you guys two pictures. So suppose right here I have my roads, and of course here it will be my intersection. And let's say car A is right here, which is going toward the west, and then car B is down here because it's going toward the north, right? Well, we know that because A is going toward the west, this distance here, and likewise car B is going up, which is this distance. And we would like to know how fast are the cars approaching each other, meaning the distance between them right here, alright? And as you guys can see in the next picture, we care about that instant when A is 0.3 and B is 0.4 miles away from the intersection. So I will label this for you guys. Because this is for car A, I will just label this as A. This is for car B, I will just label this as for car B. And this right here, when you have A, when you have B, of course, let's label this as C. In this situation, A, B, C, they are all changing. They are all functions of time. And in the next picture, you'll see A is closer to the intersection, and likewise B is also getting closer to the intersection, and the distance between them is also being shortened, right? So as you guys can see, you still have the ABC. I'll write down. We care about the moment at the instant. A is 0.3 and B is 0.4. And of course, from this we can figure out C, but let's get back to this right here. So I will look at this again and grab information. Right here it says car is traveling 50 miles per hour. So this is telling me that I will have dA dt equals to 50 miles per hour. And right here, car B is traveling at 60 miles per hour. So I'll write it down as dB dt equals to 60 miles per hour. However, though, before we continue, remember A and B, they are going toward the same intersection. So the distance of A is actually getting shorter. Likewise, the distance of B is also getting shorter. So technically, this right here should have been negative 50 miles per hour. And right here, this should also have been a minus, right, negative 60 miles per hour, because the distance is getting shorter right here. All right, and we would like to know at what rate are the cars approaching each other. So this is telling us we want dC dt based on our labeling. Okay, so we can come back right here. We know here we have a right triangle. Of course, the famous a squared plus b squared equals to c squared. And notice I wrote down a, b, and c right here. This equation is with 3 variables because once again, they are all changing. They are all functions of time. I cannot plug in any numbers right here. Okay, you can only do so if you have any constant, just like the previous example. But right here, I will just keep it as a squared plus b squared equals c squared, and then differentiate this with respect to time. Right here, we'll get 2a dA dt, and then we add it with 2b, and we will have dB dt, and then this should be equal to 2c dC dt. So this is really, really nice. And again, you can divide everything by 2, but it's okay because most likely we can just use a calculator, so it doesn't really matter. I will just keep it as how it is. I think it's nicer, so you can see the 2's. I don't know. Anyway, I keep the 2 and then the a. We care about the instant when a is 0.3, so let's put that down. And the a dt, as we discussed it earlier, that should have been negative 50. So I'll put down negative 50. And this right here is actually crucial. If, for example, maybe A is going toward the intersection, while B is going, if A is going away from the intersection, while B is going toward the intersection, then in that case, the A dt will be positive, and then the B dt will be negative. So you really have to pay attention if the rates are positive or negative. And if the distance are getting shorter, that's why we have the negative rate. Alright, then we continue. Plus 2, and then the B is 0.4. Let's put that down. And then the B dt is negative 60. So let's write that right here. And this is equal to 2 is 2. C, well, at the moment now when we have A and B right here, we also need to figure out what C is, and that's a quantity. I will have to plug into this quantity equation to help me out, right? So I will get 0.5 because it's 345. So, but I will show you guys the work anyway. Anyway, 0.3 square plus 0.4 square. That's equal to C squared, and then you can seriously just work this out. You will get 0.09 plus 0.16, which is 0.25 equals to C squared. Square root both sides and take the positive value. You get 0.5. Anyway, that's for C. And then you can just work this out, and then you have the dc dt right here. And the beauty of this is that look at this. 2 times 0.5 is just 1, so we have dc dt right away. So I didn't divide everything by 2. That was nice, huh? And then you can of course just use a calculator also, just like typing everything if you would like, and then seriously just work everything out, and you will end up with negative 78. Alright? So you can answer it in 2 ways. You can say dc dt is negative 78, and put on the units, which is miles per hour. I will just write this down right here. Miles per hour, like this. And you notice, because the rate is negative, that means the distance is getting shorter and shorter. So you can also say the following: the cars are approaching at a rate of 78 miles per hour. And if you use the word approaching, you don't need to have the negative sign for the rate. And this is it. Hopefully this helps, and if you guys want to see more, be sure you guys check out the description for the link to the playlist and also to the file of the questions. And that's it.